In this video, we are going to discuss a very important concept, concurrency control techniques. For that, we have to introduce lock. What is lock in our DBMS or transaction processing? A lock is a variable associated with a data item that describes the status of the item with respect to possible operations that can be applied to it. Actually, there is one lock for each data item in the database. Binary lock. What is binary lock? Binary lock can have two states or values, locked and unlocked, 1 or 0. A distinct lock is associated with each database item X. If the value of the lock on X is 1, item X cannot be accessed by a database operation that requests that item. If the value of the lock on X is 0, the item can be accessed when it is requested. So this is the basic concept of binary lock. So there is disadvantage of binary locks. It is similar like serial transactions. If one transaction is accessed one data item, that data item is not accessed by other transaction. This is a simple thing. For that reason, we introduce some other lock, which is nothing but shared lock or read lock, exclusive lock or write lock, and unlock. So we are now introducing three locks: shared lock, exclusive lock, unlock. Now what is shared lock? We should allow several transactions to access the same data item X if they all access X for reading purpose only. This type of lock is known as read lock. A read lock item is also called shared lock because other transactions are allowed to read the item. Now we are coming exclusive lock. What is exclusive lock? If a transaction is to write an item X, it must have exclusive access to X. For that reason, a different type of lock is allowed here. This is known as write lock. Write lock is also called exclusive lock because a single transaction exclusively holds the lock on that item. If we don't need that item, we use unlock. Now for memorize this shared lock and exclusive lock, we can remember this chart. If one transaction allow shared lock on a data item, then can other transaction can allow shared lock on that data item? Yes, because it is shared lock and it is used only for reading purpose. If one transaction is holding shared lock on a data item, then can other transaction can take this item as exclusive lock? False. If only one transaction, if suppose there are n transaction T1, T2, Tn, now only one transaction if holds shared lock on a data item, then no other transaction can holds exclusive lock on that data item. if one transaction holds exclusive lock on one data item, then no other transaction can hold shared lock on that data item. If one transaction holds exclusive lock on a data item, then no other transaction can hold exclusive lock on that data item. So this is a brief chart for shared lock and exclusive lock. Okay, now take us one example for this, how read lock and write lock works. So transaction T1 apply read lock, holds read lock on data item Y. Okay, then it read the item and it unlock Y. Okay, at the meantime, transaction T2 holds read lock on X, it read the item X and unlock X. Here, in between these two transactions, no one holding any lock on X, because here unlock Y, here unlock X. So, transaction T2 can apply write lock here, because no other transaction holding any types of lock in Y. So they are applying write lock on Y, and transaction T1 is applying write lock on X, because transaction T2, there are two transactions participating here. Transaction T2 unlock the read lock, so no other transaction applying holding any types of lock on data item X. So write lock can be applied on X by transaction T1. So it read the item X and write the item X and write item X and unlock X, here unlock Y. Now the question is, this is one example of lock, read lock, exclusive lock, how we can apply in transaction. Now if we give X equal to initial value X equal to 20, Y equal to 30, then if these two transaction happens, then here the result of X is 50, result of Y written is 50. But actually, if the two transaction happens serially, then if T1 followed by T2, then value of X will be 50 and Y will be 80. And if the T2 followed by T1, value of X is 70 and Y is 50. So even if we applied here lock, the transactions are not giving the accurate result. Okay, for that reason we are taking two-phase locking protocol. Now, what is two-phase locking protocol? This protocol is the name two-phase because it has two phases. One is expanding phase or growing phase and another is shrinking phase. So what happens in expanding phase or growing phase? In growing phase, we first lock all the items that are needed lock. No other item, if the growing phase, if in the transaction growing phase ends, no other item can be locked further. Okay, during this phase actually we acquire new locks on item and no item can be released at that time at the growing phase. So in our transaction in two-phase locking protocol, it has two phases. In growing phase, in that phase, in growing phase, only new locks can be acquired on the item and no item can be released or unlocked in growing phase, and in shrinking phase no new lock can be acquired, only the existing locks can be released, okay, in the shrinking phase. So there are two phases in two-phase locking protocol, one in expanding phase or growing phase. In this phase, transaction acquires only locks, it will not release any lock, and in shrinking phase it will not acquire any new lock, it will just release the locked item, okay. So if we consider the previous example, this example, and if we set this example according to two-phase locking protocol, then this example will be like this. We only T1 dash is a transaction, it acquired lock, read lock on Y, read item Y. Transaction T2 dash simply read lock X, read item X, and then it need transaction T1 need read lock on write lock on X, then it requests for write lock on X, same as transaction T2 dash write lock on Y, and when it unlock Y, that means up to this is growing phase, and when it unlock, no other lock can be issued by transaction T1 dash. So is releasing Y and then it releasing X. Here also transaction T2, when it unlock X, it releasing X, then it releasing Y. No other lock will be issued on that if shrinking phase is started. Okay, the above example is an example of two-phase locking protocol, and two-phase locking protocol guarantees serializability, it guarantees conflict serializable, okay, conflict serializability. So when we use two-phase locking protocol, it ensures us that the transaction will be free from lost update problem or dirty read problem, because it is assures us that this transaction will be conflict serializable, okay. But two-phase locking protocol does not free from deadlock. The above example is a theoretical example of two-phase locking protocol. Actually, when T1 dash and T2 dash, neither T1 dash nor T2 dash make progress, because when executing T1 dash, executing write lock X, it will cause wait to T1 dash, because for T2 dash to release lock on X while executing lock write lock Y causes T2 dash to wait for T1 dash to release lock on Y. Such condition is called deadlock. Okay, so up to this we can see two-phase locking protocol is not free from deadlock, but it guarantees serializability. So there are different variation of two-phase locking protocol. One is conservative two-phase locking protocol, another is strict two-phase locking protocol, another is rigorous two-phase locking protocol. So what is conservative two-phase locking protocol? In conservative two-phase locking protocol, the transaction requires to lock all the item it access before transaction begin execution. This is known as pre-declaring read set or write set. Okay, so what is pre-declaring of read set? This is the meaning that the transaction is the set of all item that transaction reads, and what is write set is a set of item that it writes. So if any of the pre-declared item needed cannot be locked, the transaction does not lock any item. It waits until the item is available for locking. In that scenario, conservative two-phase locking protocol is deadlock free protocol, but this is unrealistic protocol. It is difficult to use it in practice because if any of the item read set or write set, any of the item is not acquired for locking, it will not lock any of the item in read set or write set, which is not possible in most situations. And what is strict two-phase locking protocol? This is in this strict two-phase locking protocol. In this variation, a transaction does not release any of its exclusive lock until after it commits or aborts. So no other transaction can read or write that item that written by that transaction until the transaction is committed. So this is strict two-phase locking protocol, and this strict two-phase locking protocol is not deadlock free protocol. And rigorous two-phase locking protocol, in this protocol a transaction does not release any of its lock until the transaction commits or aborts. So here no exclusive lock is released until the transaction commits, and here no locks released until the transaction commits. Okay.